teach you is how to factor. Now all you have to do to factor is follow these step-by-step directions, and no matter what it is, just follow these directions and everything will end up working out. So we're going to start with this problem right here. Okay, so let's go back to the directions. The first direction is look for GCF, which means greatest common factor. So when you look for the greatest common factor, you have to look for a number or variable you can that all of them have in common that you can pull out. So first what you want to do is pull it out of the radical. So just get rid of this radical right here. Just pretend like that doesn't exist for a second. Okay, so we have to find something that both of these have in common. So right now, the only thing I can see that both of these have in common with is a 3x. So I'm going to pull out the 3x. Now you have to divide everything inside by the greatest common factor. So 12 divided by 3x ends up being 4x squared. And then 27x, take out the 3x, will end up being a minus 9. Okay, so now we have that. The next direction is determine the number of terms. Alright, and right now we know that it has 2 terms right here. So we go back, and if there are 2 terms, you may have to use a factoring formula. Difference of squares, difference of cubes, or sum of cubes. Alright, we're going to look at it. This is difference of cubes. This one's difference of squares. This one's difference of cubes, and this is sum of cubes. We look back at it, and we have a 4x minus 9. 4x squared and 9 are both perfect squares. So the only thing we can use is the difference of squares. So we look at this right here. This term is a squared, and this term is b squared. So if a squared equals 4x squared and b squared equals 9, we have to figure out what just a and what b are. So what we're going to do is we're going to take the square root of all of these, and we'll end up getting a equals 4x. That's a common mistake. Always make sure that you remember to take the square root of the number in front of the variable too. So the square root of 4 is 2, and the square root of x squared is x. So it's 2x, and then b equals 3. So we have, now we go back to the formula of difference of squares, and we look at it right here. This is what we have to plug in. A plus b, and then a minus b. Okay, so a plus b, a plus b, and then a minus b. Now you can take that a little bit further by factoring out these, by dividing both of them by 2, and then you can get x plus 3 halves, and then x minus 3 halves. And that's how you factor out when you have 2 terms. Since that was a difference of squares problem, if you ever have a difference of cubes or a sum of cubes problem, it's really easy. All you have to do is follow the same steps as a difference of squares problem. And you find out what a and b are, and then you plug them in to the equation. So just put a plus b, then these ones are different. You put a squared plus ab plus b squared. And then this one's a squared minus ab plus b squared. That's how you would do it if there's 2 terms. But say there's 3 terms. This is an equation with 3 terms. Now we start at the beginning again, go back to the instructions, look for greatest common factor. That's always your first step. Because looking at this, you can't just factor it out. Some three-term functions, you can just factor them out immediately, but always make sure you look for the greatest common factor first, because that's where a lot of mistakes come in. So greatest common factor here would end up being 5x squared. And then you end up with x squared plus 12x plus 35. Alright, and now that you have a 3-term function right here, you can just factor out from standard to factored form by figuring out two numbers that multiply to be this number and add up to be this number. So in this case, 7 times 5 is 35, and 7 plus 5 equals 35. So those are the two that we're going to be. See, both of these are positive. So they're both of the solutions are going to be positive. So you just write the two solutions in factored form, x plus 5 and x minus. Oops, that's supposed to be a 7. X plus 7. And always remember to bring down the greatest common factor. That is completely factored. Now we move on to a 4-term function. A 4-term function can actually be factored in two different ways. You always want to look to make sure that it can be grouped before you can look at it before you look for dividing it, because grouping is easier. So you want to try and avoid long division. You want to check to make sure it can't be grouped before you go to long division, because this way is a lot faster and it's a lot easier. What you do is you split it up into two groups, and the only way for grouping to work is if this number and this number have the same ratio as this number and this number. And in this case, that's true. So we take the two groups and we factor those groups out individually. So factoring out this first parenthesis, the first thing we would do is find the greatest common factor. And right here, greatest common factor would be x squared. So factor out the x squared, then leave what's left, x plus 15. And then do the same thing with this side. The greatest common factor is a 9, and leave x plus 15. Make sure this is plus 15, because if these two aren't the same, then this won't work. So now we can factor out of this whole solution something that it has in common. X squared times x plus 15, 9 times x plus 15. What do those two have in common? It's the x plus 15. So now we're going to factor out the x plus 15. So we put the greatest common factor, which is x plus 15, on the outside. And then leave what we have left, which is this and this. So now we have x squared minus 9. And so now we have these two parentheses, and now we factor those ones out once again. So we look at this one right here. This one's completely factored, so we just drop that down, x plus 15. Now x squared minus 9, that can still be factored. See, x squared and 9 are both perfect squares, so all you have to do is take the square root of both of them, and you have x plus 3 and x minus 3. So the square root of 9 is 3 or negative 3, because negative 3 squared is 9, and then 3 squared is 9, because a negative times negative equals a positive. So either way it's going to be 9, so it could be either one. So we have to put both solutions down. And this makes sense because at the beginning of our equation, this number is a 3, and then we end up having 3 solutions. Now the second way to factor out a 4-term function would be long division. Now usually when you have to divide a 4-term function, you have an x-intercept, and this has an x-intercept of x plus 1. So we're going to put that right here, and you just divide it by the x-intercept. So it's just normal long division. So we take this, and we go x goes in times y equals 3x squared, and 3x to the third, and that is 3x squared. So 3x squared times x is 3x to the third. And then we multiply this one to this number. So we have 3x cubed plus 3x squared. And now we minus this whole quantity. So we end up with 0 right there, and then we end up with 2x squared there. And then we drop down the next term that comes next. So we drop down this 0x. Now, we do the same thing. So x goes into x, 2x squared, 2x times 2x times x is 2x squared, and then multiply back again, and so then we have plus 2x, and then we minus that quantity again, we get 0, and then this time we get negative 2x, and then we drop down the next term again, and then we get minus 1, so then x goes into negative 2x, negative 2 times, negative 2x, multiply back again, negative 2 times 1 is negative 2, minus this whole quantity, and we go negative 2x minus negative 2x equals 0, and then negative 1 minus negative 2 equals 1. So we end up getting a remainder of 1. So when we write this out, we take this here, right here, and we put it right here. When you get a remainder, you take what you get on top, and you just put it, the remainder, over the x-intercept. So it'll look like this. That's what it looks like when you divide a 4-term function and you get a remainder. But say we got something more like this on the top of that division sign after we got done dividing that 4-term function. Well, if we take that and we put it here, this is what it'd look like on top of the division sign when you don't get a remainder. And then from there you would just factor out what you got on top of the division sign. So right here we'd factor out like we did before, x plus 7, x plus 5. But whatever we put on the outside of the division sign, which was x plus 1, this number right here, we have to put that as a solution too, because we were given that as an x-intercept, because all these solutions are x-intercepts. So you end up with these 3 solutions if that's what we got on top of the division sign before. So don't forget to bring down the solution that you were given before you divided the 4-term polynomial. Okay, I have some of these problems we just got finished doing. I brought down the greatest common factors and put them in their fully factored form, which we already did, and I just showed you how to do. Now we're going to learn how to factor them. We're going to learn how to graph them from factored form. Now the first thing you want to do when factoring something is you want to figure out the degree of the function. This can be done by looking at either your solutions or your standard form, the form that it was in when you got it. I think it's easier to look at it in the standard form. All you have to do is find the highest power, like right here, here, or here. So we know that the highest power is the degree. So this one would be 2, this one would be 4, this one would be 3. And if it's an even degree, then you know that your arrows are both going to end up pointing the same way at the end of the graph. And you can look at the A value, whether it's positive or negative. That tells you whether your graph is if it's an even degree, it'll open up and look like this. That's if it's positive. But if it's negative, it'll go like that. But if it's a odd degree, it'll look something more like this and like this. Or if it's a linear, it'll look like that. And you also want to look at the radical. If it's underneath a radical, the graph's it doesn't affect the graph at all, but it affects the domain. And we'll talk about that in a second after we learn how to graph these. Now, I'm going to graph this one just because it has something special about. I'm going to show you in a second. And we'll also graph rationals later, but we're not going to talk about that yet. So let's go on to graphing. The first thing you want to do is plot the x-intercepts. Let's go to the graph here, and I'm going to put the solution down in the bottom so that you can see it. Now, when you're looking for x-intercepts, you want to make what's in these parentheses equal to 0. Okay, so what plus 5 equals 0? Put a negative 5 there. Negative 5 plus 5 equals 0. And then negative 7 plus 7 equals 0. A lot of people say just flip the signs, but where that comes from is from making the parentheses equal to 0. So, let's go. Negative 5 and negative 7 are our x-intercepts. So, there's negative 5 and negative 7. But there's another thing here. There's this right here. When there's an x by itself, you look at it the same as x plus 0. And then you put the opposite in for x. 0 plus 0 is what makes that equal to 0. So, when you have an x by itself on the outside, that just means an x-intercept of 0. So there's our x-intercept of 0. The 5 is just the slope of the line. It's the A value, and that doesn't really affect the graph that much. It just affects the slope of the line. Okay, so there's something special about that x on the outside by itself. It has a squared. So if there's an x squared, that's equal to x plus 0 and x plus 0. So it's like there's 2 in there. So it crosses twice at 0, which seems impossible, but it crosses twice somewhere in there. So that turns into a bounce on the graph, which looks like this. It hits the y-intercept and bounces back up. So it doesn't necessarily cross it, it just bounces right off of it. So not only do we have an x on the outside by itself, which makes an x-intercept of 0, but we also have a bounce in the graph. So now let's graph this. Like I said before, we have to figure out the degree. Well, we used this one, and the degree is the highest exponent in standard form, and it's 4. We can also add up the exponents of all the x's in factored form. This 1, that's a 1, equals the same thing. 1, 2, 3, 4. So either way, the degree is 4. So the degree is 4, which means it's even, which means at the end of the graphs, the ends of the graph, the lines are going to be pointed the same way. The arrows are going to be pointed the same way. Now we have to look at the A value to figure out if it opens up or opens down. Well, the A value is positive 5, so it's positive, so it opens down. This is what it looks like when an even degree has a positive A value. It looks like a U like this, like a parabola sort of. So we can start by putting our arrows in like this. Now that we have the arrows, we just go through all the x-intercepts. Go through that one, go through that one, and then, oh, we don't go through that one, do we? What do we do instead? We just back it up, and bounce off and head up. See, if we did just go through that one, we would end up going through it and down, and then our arrows would be pointed different ways. And we don't want that because we have a degree of 4, which is even, and we have a positive A value, so it's open like that. And that's what your graph would look like. Now that's not all though. A lot of the time when you're given a function like this, you're asked to give the domain. The domain is anything that the x can be. Anything that the x can be. So you want to look anywhere on the x-axis that coordinates can be. So right now this would be from negative infinity to positive infinity. However, that's not what we're graphing. We're graphing this, which is underneath a radical. And have you ever gone into your calculator and tried to take the square root of a negative number, say negative 5, or let's say negative 25? It doesn't matter. Anything negative under a radical equals an imaginary number. And we don't want those. So when your function is under a radical and you're trying to graph it and you have to give the domain, it's only positive values. So that means anything that is above the x-intercept. I mean the x-axis. So any part of the line that is above the x-axis. So it can be anything over here, anything right here, and anything all the way over here. So it can't be right here, because see, it's below the x-axis. We can only have positive values, only over. So now what we do here, to write the domain, all we have to do is say where it's positive. So it's positive from all the way over here as far as you can. So we're going to call that negative infinity to right here, which is negative 7. And then we put a u between it. It's called union. Oh, and you want to include negative 7, because we can take the square root of 0, and at negative 7 it's 0, right? Because it's an x-intercept. So we include negative 7. So it ended up looking like this. Negative infinity to negative 7. And then we want to also include from here to here, which is negative 5 to 0. Including 0. And then put another union sign. I'm running out of room here. And the next one would end up being from 0 to positive infinity, including 0. See how we have an including 0 and an including 0 twice? We can just join these two together. So it ended up being negative 5 to infinity. So our full domain would look like this. This would be our final domain. See, from negative infinity to negative 7, then negative 5 to forever, or to infinity. That's our domain. And that's how you would graph any of these. There's only one more thing that I want to say something about, is what if you have like x plus 5 squared and then x plus 7 cubed. See, we already know what the squared means. We'd put the negative 5 in there and figure out that's our x-intercept. And we know that we're going to bounce off of it. See, but what if we have a negative 7 with a cube over it? See, that's an odd degree. What if it has an odd degree? Well, let's say this is -7. It crosses 3 times, which means it bounces off but then goes back down. So if it's an odd degree, we do something called a curve through, which will come down like this, stop, it'll curve a little bit, and then it'll go back down. So watch out for that. If there's any with an even degree, it's a bounce off. With an odd degree, it's a curve through. That's just something that didn't work with any of the equations that I had. And that's all you need to know about factoring, graphing, and finding the domain of any function, except rationals, which we're going to get to.